Hello, students. This is the second session, Unit 2, Basic PLC Programming. In this session, we'll be studying about various PLC input instructions, PLC output instructions, and the input devices and output devices which can be connected to the PLC modules. Here, there are five different types of input instructions available, which you can use for programming the PLCs. These input instructions can be used to examine the state of the external PLC inputs. That is, I want to know what is the state of input switches, push buttons, and limit switches, or the state of the sensors. So, all these things can be examined using the input instruction. So, basically, the input instructions are used to examine the state of the external inputs connected to the PLC module. Now there are five different input instructions which you need to understand. The first one is the normally open contact, and here I have shown the picture of NO contact here. So you can see in this picture, the first picture shows there is an energy flow. Okay, and the second picture you can observe the energy is blocked here. So it means that under the normal in normal operations, the NO contact will be open. So when the under the normal operation, normally there is a normally open inputs like normal open relays. By default, they do not create a connection between the two power rails. Only when the contact is activated or energized. In that case, the contact will be closed and the energy flows from one power rail to the another power rail. So this you can see here. Here the energy is blocked because the contact is open here. So when this contact is open, there is no connection between the two power rails. Hence, the output element which is connected in this line will be de-energized. So, because the energy is blocked. This is the normal operation, and whenever this contact is energized, that is, the contact closes. In that case, it establishes a connection between two power rails, and there is a connectivity between the two rails. Hence, the current can flow from one rail to another rail and power will be transferred to the output coil. And the output devices which are connected to the output are now energized or they become activated or it will be powered up. So here the inputs I was talking of could correspond to input devices like the switches, limit switches, or it could correspond to sensors which are used to activate the output device conditionally. That is, only when some conditions are met. Only in that situations the output device has to be activated or energized. So in such type of situations, we will be using the input instruction like NO contacts. So during the normal operation, an NO contact, what it does is by default it is open. So there is no connection between the power rails and energy will not flow from one rail to another rail and output coil is not energized. Only when the contact is energized, that is, contact is closed. In that case, there is a connection between the two rails, and hence current can flow and power will be transferred to the output device. The next instruction is normally closed contact. Here, by default, the contact is closed, and only when it is energized, the contact will be open. So, a normally closed contact, by default it is closed. That is, it corresponds to this first image here. So it is normally by default it is closed. Hence, because it is closed, the contact is closed. There is a connection between two rails, and hence current will flow from one rail to another rail. And this second image shows that here the contact is open. So when the contact is open, there is no connection between the rails, and hence there is no current flow through the output coil. So all the output devices which are connected to the output coil will be turned off. Normally closed inputs. So normally closed inputs, the NC contacts, these are used uh, to represent the stop buttons, and they can be used to represent emergency shutdown devices. Whereas your NO contacts, they are used to here you can see the NO contacts, they are used to represent an input device and sensors, whereas the NC contacts are normally used to represent a stop button or a emergency shutdown devices. And this normally open contact, it's also known as examine if closed contact. The NO contact is also called as examine if closed. It means that it is default open, so you are trying to check the status of a NO contact by executing this instruction examine if closed. So only when if it is closed, only when the NO contact is closed, then the output device will be energized. Whereas the NC contact, normally closed contact, it is also called as examine if open. Examine if open. This means that by default the NC contact is closed. So there is a connection between two rails. Only when it is energized, it becomes open. So when it becomes open, some functions will be carried out. Therefore, this contact is also known as examine if open. And the third input instruction we use is latch and unlatch latch and unlatch instructions. Here there are two inputs here. When the latch input is on, the output element will be energized, and it remains energized until the the on condition appears on the second input called the unlatch. So the latch and unlatch system would use two inputs, the latch input and unlatch input. When the latch input goes high, the output element will be energized, and it remains in the say energized state even if the latch input is turned off. And if I want to turn off the or de-energize the output element, then I need to turn on the unlatch input. So when the unlatch input is turned on, the output element will be de-energized. So we are using here two inputs, the latch input and unlatch input. The next two instructions, they are related to the transition of an input. Here, in the earlier three instructions, that is NO contact, NC contact, latch and unlatch system, the output element was energized or de-energized based upon the levels at the input line. Whereas the next two instructions which you are going to study, here the output will be energized or coil is energized only at a particular instance of time. So the first thing here is the rising edge actuation. The function turns on for one scan time at the leading edge of a input signal pattern. That is, whenever a input signal goes or changes from off to the on state, there we see the rising edge. Okay, whenever the input signal changes from off to on state, we will have a rising edge. Only when that rising edge occurs, at that particular point of time, your contact will be energized, and the energy flows from one rail to another rail. This will energize the output coil. And here the energy becomes blocked. The energy is blocked, or connection between the two rail is ended only when the input changes from on to off state. So this is about the rising edge actuation. On contrary to this, we also have falling edge actuation. Here, whenever the input changes from on to off state, that is the first image here, on to off state, then the contact will be closed, and there is a connection between two rails, and the output coil is energized. And here you can see it, the output, it becomes energized, or the output will be turned off only when the input makes a transition from off to on state. So these two, that is the rising edge and falling edge instructions, they depend upon, I mean, they are based on the transitions of the input signal. Whereas the NO contact, NC contact, latch, unlatch system, they depend upon the level of the input signal, whether the input signal level is 1 or 0. It depends upon the level. Whereas the rising edge and falling edge actuations, they depend upon the timing of the transition. At what time the transition occurs, at that particular time, the contact is energized, it closes and completes the circuit. And in the next slide, we'll see some of the input devices that may be connected to the PLC. Here, I've shown the input switches along with their symbols. So you can have pressure or and vacuum switches, the liquid level switches, which indicates the level of a liquid, then temperature actuated switch, flow switch is there, then we have selectors. In that selectors, you have two position selector and three position selector switches. Then the push buttons, and here you also have foot switches, and then the limit switches. So all these switches are used as input devices, and even sensors can also be used as the input device. And these devices, they are represented in ladder diagram as contacts. So there is a difference between a switch and a contact. So switch is the external device which is connected to a PLC module, whereas the contact is a electrical component which is found inside the switch, relays and connectors. Each contact is a piece of electrically conductive material like metal. So your contact consists of a conductive material like the metal, and whenever a pair of contacts, that is pair of metals, come in touch with each other, then current can pass through it. So there is always a difference between a switch and a contact. Switch is the external input device which is connected to the PLC module, whereas the contacts means the switches are represented in the ladder diagram using contacts. So I think I have cleared uh, doubt between what a switch and what a contact is. So switch is different and contact is different. Switch is external device which is connected, whereas the contact is, it is a contact means the switches are represented in ladder diagram as contacts. I think it's clear. And next, we'll move on to the output instructions. So here we have three types of output instructions. The first one is the output energize, also known as OTE instruction. Here you see here, and this is the link. This is left link, and this side is called as a right link here. Here, the condition of the left link of the OTE, if it is turned on, then this device, output device, remains set. It will be turned on. So only when the condition of the left link of OTE is energized, the output remains set. Then we have the negative output energize, NOE. Here, when the condition on the left link of the NOE is turned on, then the output device will be on here. So when the condition of left link of the NOE is off, turned off, then the output is energized. So these two, OTE and NOE, they are opposite to each other. That's why I put uh, or a line here. This you can see, you can observe here. So, whereas OTE means output energize means only when the condition on the left link becomes on, the device output coil will be energized. For negative output energize, the output becomes on only when the condition of the left link becomes off. The third type of output instruction is called output latch, output unlatch instruction. So here you can see OTL and OTU. If the condition of the left link of the OTL is momentarily on, then the output remains set. That is, this condition to the left of OTL is momentarily on. Momentarily means only for short duration of time it is turned on. In that case, the output will remain set, or the output coil will be energized. And the same condition, even if the condition to the left switches off, that is, even if the condition on this left is switched off, here the output will be on. Here the OTU is called as the output unlatch output unlatch, the output remains set until the condition of left link of the OTU is momentary on. That is, the condition to the left of this OTU is momentary on. Even, even then, also, then the output remains set here. Now we'll go to the output devices which can be connected to the PLC module. Here for the output coil, we can connect these output devices. We have the DC motors which can be connected. Then you have series and shunt coils can also be connected. You can connect annunciators, bell, buzzers, horns, sirens, and some type of meters which make the measurements, and the pilot lights. All these things can be connected to the output coil. Now let's recap what we understood in this session. So the first thing we went was the input instruction. There are five input instructions: NO contact, NC contact, latch unlatch system, then rising edge actuation, falling edge actuations. This is NO contact. NO means by default it is open only when it is energized, the contact closes, and energy flows between the power rails. And for normally closed contact, by default, that is normal operation. Under normal operations, the contact is closed only when it is energized. It will be opened, and energy will not flow between the rails. And this NC contacts are used to represent the stop buttons, emergency shutdown devices, whereas NO contacts are used to represent the input devices and the sensors which are used to conditionally activate the output. That is, some conditions are to be met in order to activate the output. In such cases, I'll be using the sensors and input devices, which are normally represented as NO contacts. The third type of instruction we went through was the latch and unlatch system. And here we will be using two inputs. To turn on a output coil, I need to uh, have high on the latch input. So the latch input has to be energized, then only the output coil is turned on. And even if the input is turned off, your output still remains to be on because it's a latch system. And to turn off the coil, I need to send a input on the unlatch input. Then we have a rising edge actuations and falling edge actuation. These two input instructions, they work at one particular instant of time. In case of rising edge actuation, whenever the input signal changes from off to on, that is, there is a rising edge. At that point of time, your contact will be energized and it closes, and there is an energy flow between two power rails. And falling edge actuation is where whenever an input changes from on to off state, when the input has changed from on to off state, at that particular time instant, the contact will be closed and there is an energy flow. And some of the input devices which may be connected are these. You have the pressure and vacuum switches, liquid level switches, temperature switches, flow switches. Then we have selectors, push buttons, limit switches, food switches. So all these things can be connected as an input device to the PLC. And you should note that there is a difference between a switch and a contact. The switch is the external device which are connected to the PLC module, whereas whereas the switches are represented in the ladder diagram as contacts. So there should be a difference between, that is, a switch is different and a contact is different. Switch is represented as contact in ladder diagram. Now let's move on to the output instructions. We have three types here. The output energize OTE. Whenever the condition of the left link of OTA is turned on, then the output coil is energized. The negative output energize here whenever the condition of the left link is turned off, then the output coil will be energized. The third output instruction is output latch and output unlatch system. So here, if the condition of the left link of OTL is momentarily on, the output will be set, and it remains set even if the condition of switches to the off state. The output remains set until the condition of the left link of the OTU is momentarily on. So some of the output devices which may be connected are the DC motors, coils, bell, buzzers, meters, sirens, and pilot lights may be connected as the output devices. Now let's move on to the quiz section. Here I've shown the first question is I've shown a symbol. It represents, the options are NO contact, NC contact, rising edge actuation, none of the above. The answer is NO contact, choice A. The second question is symbol of NC contact is, and here I have shown the contacts. Picture of uh, contacts I have shown here. So the NC contact is represented by two vertical lines. On that I have put a slash mark. That represents your NC contact. So the answer is choice B. The third question is which of the statement is true of NO contact? The first choice, when contact opens, the function carries out some kind of action. B. When the contact closes, the function carries out some kind of action. C. This contact turns the function on at the leading edge of the input signal. D. This contact turns the function on at the trailing edge of the input signal. So, for an NO contact, this is true. When the contact closes, the function carries out some kind of action. So, the answer is choice B. The fourth question is name the input instruction wherein one input is used to turn on the function, second input is used to turn off the function. The choices are NO contact, second is NC contact, C rising edge actuation, D latch unlatch system. The answer is latch unlatch system, option D. That is, to turn on a function, I need to send a high on the latch input, and to turn off the same function, I need to send a high on the second input called unlatch. So latch unlatch system is the answer. The next question is name the input instruction wherein the function turns on at the leading edge of the input signal. The options are latch unlatch system, rising edge actuation, NC contact, falling edge actuation. So whenever the input signal at the leading edge, that is whenever the signal changes from off to on state, we have the leading edge. So the answer for this question is the rising edge actuation. That is choice B. So rising edge means input changes from off to on state. At that instant of time, the contact will be energized and there is a connection between two rails. The sixth question is at the trailing edge of the input, the signal. The choices are changes from high to low, changes from low to high, remains constant, none of the above. The answer is high to low. Choice A. So trailing edge occurs when the input signal changes from high to low. The answer is A. Seventh question is PLC input devices are push button, limit switch, selector, motor. Select the correct option. So here I've shown the combination. Here you need to be very careful while answering this type of questions. So here you see the combinations. Here the input devices which can be connected are the push button, limit switches and selectors. So ABC combination. That is the fourth option. Whereas motor is always a output device. The next question is in PLC programming, coil corresponds to input, output, interlock, seal. The answer is coil corresponds to output. Thank you.